Hey Math 20-1s, welcome to our first video lesson. So this is taking me a couple takes to get down, so it's all new. It's very different for me teaching to a computer versus teaching to all of you out in your desk. So we're going to do our best and we're going to figure this out. But yeah, so today we're going to start our trig unit. We did some review of the 3 primary trig ratios last week. We're going to take a little bit of a departure for today or for this lesson, on those 3 trig ratios. We're actually going to talk about something different. So hopefully you've got the notes that I sent you on Friday, and those are what we're going to use to work through the lesson. Don't worry about the scary picture that's here on the front. That's something called the unit circle that we will look at in Math 30-1. But it is trig, so it's just the cover of these notes. All right, so today what we're actually going to do is take a look at angles in standard position. We're going to do section 2.1. I'm just going to try to reorient a little bit. So the point, slight error in the notes here, we are only going to focus on the first 2 of these. So we want to be able to draw an angle from 0 to 360 degrees in standard position, as well as determine the reference angle. So we obviously have some vocabulary that we're going to need to do as well. And then we also want to be able to determine the quadrant in which the angle terminates when it's in standard position. We are not actually going to do these other 2 points here. We are not actually going to figure out trig ratios at all, and we're not getting into any problem solving today either. So those are no's. Okay. So let's dive into our vocabulary. So when an angle is in what is known as standard position, the vertex of the angle must be here at the origin. So basically what we're doing, let's backtrack for a sec. An angle in standard position is that we are going to put an angle on the coordinate grid in a very particular way. Okay? So the first point of it is that the vertex of the angle must be here at the origin. So the vertex of the angle has to be there. The what we call the initial arm, so you can kind of view it as the starting arm, that always lies on the positive x-axis, always. And then the terminal arm, so the arm that rotates in a counterclockwise way from the positive x-axis to create the angle, that's our terminal arm, that's going to lay somewhere in the 4 coordinates of the coordinate grid. So for this first one, we have it lying here. And so this then is our angle. So this is what an angle looks like when it is in standard position. We've got the initial arm on the x-axis, positive x-axis. We've got the terminal arm somewhere on the coordinate grid, and our vertex is at the origin. Okay? And as it says there, as a note, the angle of rotation is always counterclockwise. When that is true, then, and we're going to see sometimes in the future, in grade 12 specifically, when we go in a clockwise way. However, when we go in a counterclockwise way, that means that the terminal arm goes in this motion, right? So around the x-axis in that way, then you have a positive angle. If we were to go clockwise, then we would express our angle as a negative. So kind of like we do in physics, where the sign is actually related to direction. Okay. So that is an angle in standard position. So here's just some examples. So this first one, obviously, is when the angle is in standard position. And the second one here is an angle that is not in standard position. Right? This one's not in standard position because of this arm, this being the initial arm, and it is not on the positive x-axis. It should be down here. So you shouldn't see an angle like this. This is just not in standard position. All right. So the first thing we're going to do is sketch an angle in standard position, and from that then be able to determine what quadrant the terminal arm lies in. So this is going to be a little bit of estimation. You could, of course, if you wanted to be super accurate, pull out a protractor and use it. I'm not going to suppose lots of you have your protractors at home. Now I do, though, want you to think and estimate kind of appropriately, right? An estimate isn't just that we're going to put the arm anywhere. We do want to think about our estimates accurately. Okay, so I'll explain what I mean by that. So here we're going to do a first one, 75 degrees. So always just start out by sketching out your coordinate grid. And I'm using a new stylus for the kind of the first time, so I'm not always great yet drawing my lines. Well, there, that's a little bit better. Okay, so remember, your terminal arm or your initial arm is always going to be here on the x-axis. So a lot of times, or all the time really, guys, you don't actually need to draw your initial arm because it's always going to be on the x-axis, positive x-axis. So you really only need to draw your terminal arm. Okay, so for 75 degrees, that's less than 90, right? So your y-axis, if you think about like terminal arm to the initial arm to the y-axis, that's 90 degrees, right? So this is what's known as quadrant 1. Quadrant 2 is over here, and this is where angles that are between 90 and 180 would go, right? Because again, your initial arm is always here on the positive x-axis. And then quadrant 3, which is down here, this is going to be for angles that are between 180 and 270 degrees. And quadrant 4, which is here, that's for angles between 270 degrees and 360 degrees. And where am I getting those numbers from? Well, because every quadrant is 90 degrees. So 2 90s is 180, 3 90s is 270, and 4 90s is 360, which of course we know is a perfect circle. Okay, so if I'm drawing an angle that is 75 degrees in standard position, it's here in quadrant 1. Now this is what I mean by saying, when I said try to draw somewhat accurately. I'm not just going to kind of put a line anywhere and say, oh, that's 75 degrees. Because that don't look like 75 degrees. That looks more, I would say, like 45 degrees, right? Halfway of 90. So try to be a little bit accurate. Again, I'm not expecting you to pull out a protractor and do this, but let's think about it, right? 75 degrees is fairly close to 90, right? Only 50 degrees off. So we want to kind of be maybe something like this, right? That's where our terminal arm would be. And here, that's our angle at 75 degrees. Okay? So then if we draw one that is 110 degrees. Okay, well, from the positive x-axis to the positive y-axis is 90 degrees. So we're going to be over in quadrant 2. Now, 110 is only 20 more than 90. So I'm going to only be 20 degrees off of 90. So maybe something like that. So the angle here then is 110 degrees. So that's an angle in standard position that is 110 degrees. And then for our third one, 330 degrees. So there's my coordinate grid. Again, don't really need to worry about drawing the initial arm, just worry about drawing the terminal arm. So 330, slightly off of 360. So I'm going almost all the way around, but not totally. So thinking, again, if I'm starting here at the positive, that's my initial arm, I'm going to go almost all the way around in a counterclockwise way. So where I would draw the terminal arm for 360 is maybe something like that. And the way the angle goes is, again, counterclockwise. So this is 360 degrees. Okay? So that's how standard position works. And then in terms of in which quadrant does the terminal arm lie, well, this is quadrant 1. So 75 degrees was in quadrant 1. This is quadrant 2. So 110 was in quadrant 2. And for our 360, we were in quadrant 4. Okay? All right, well, let's continue on. So there's a little summary. So quadrant 1, it shows you the quadrants. So 1, 2, 3, 4, and we start in quadrant 1 being the upper right one because that's where both x's and y's are positive. Okay? And there's also the summary of the angles. So quadrant 1 is for angles from 0 to 90. Quadrant 2 is from 90 to 180. Quadrant 3 is from 180 to 270. And quadrant 4 is 270 to 360, just as I explained. All right, that brings us to something called the reference angle. And reference angles are going to become really important. It's actually what we use the most when we're doing trig with angles in standard position, as we're going to see in the second topic. So there's the definition. A reference angle is always an acute angle, so smaller than 90 degrees, that you make from the terminal arm to the closest x-axis. Okay, so it's an acute angle. You make it from the terminal arm of the angle to the x-axis that is closest to. Okay, so here are 4 different examples of reference angles. So when, we'll start off in this one, talking about this one first. So when your terminal arm is in quadrant 1, then your reference angle and your angle, what is sometimes called your principal angle, are the same thing, right? Because the closest x-axis is the terminal, or is the initial arm. Okay. In the second one, so in this one, when our terminal arm is here in quadrant 2, our reference angle is the angle formed here between the terminal arm and the closest x-axis. So it's this angle. Okay? Of course, in quadrant 3, right, when your principal angle is going all the way around from the positive x-axis to the terminal arm that's in quadrant 3, so all of this, your reference angle is only from the terminal arm to the closest x-axis. So just this little piece is your reference angle. And of course, lastly, then when we're talking about an angle that is in the 4th quadrant, we're talking about going all the way around to there. That is our principal angle. And our reference angle is, again, only between the terminal arm and the closest x-axis. So just that piece there. Okay? So that's what a reference angle is. It's from the terminal arm to the closest x-axis, and it is always an acute angle. Trying to get myself centered in the video there. All right, so let's move along then. So, a couple things again to note about reference angles. A reference angle is always a positive measurement, always a positive angle, and again it's acute, so it's a measure between 0 and 90 degrees. In trigonometry, you are often given the reference angle and need to calculate the angle of rotation, meaning you need to calculate the principal angle. Okay? All right, so here's our example. We're working with a reference angle of 30 degrees, and we want to calculate the angle of rotation if the angle is in these 4 quadrants. Okay? All right, so again, I'm just going to start off by drawing little sketch of a coordinate grid. All right, it's my x and my y axis. So if the principal angle is in quadrant 1, again, your principal angle and your reference angle then are the same thing. There we go. Right, so your reference angle is here, as well as your principal angle. Okay, so the symbol we often use for reference angle is theta, which is the symbol we always use for angle, and then a subscript r, that stands for the reference angle. Okay, so that's the reference angle for quadrant 1. If your angle is in quadrant 2, So meaning your terminal arm is here in quadrant 2. Then your reference angle is from the terminal arm to the closest x-axis, so there. So this is your reference angle. Okay, now in this case, we're saying a reference, sorry, I forgot, we're actually saying we had a specific reference angle. We're saying a reference angle is 30 degrees. All right, so, sorry, I forgot that piece of the question. I was just sketching out what we'd kind of done before. Okay, so if my reference angle is 30 degrees and it's in quadrant 1, that means my principal angle is also in quadrant 1. So calculate the angle. Well, in quadrant 1, they're the same. So both theta and the reference angle are equal to 30 degrees. When our reference angle is 30 degrees, but our principal angle is in quadrant 2, what we're saying is that this is 30 degrees, because that is your reference angle. So what is your principal angle? Well, it's this, right? Well, how would we figure that out? Well, as we can actually see in the picture here quite nicely, our principal angle here and our reference angle here would add up to 180 degrees. So to figure out what our principal angle is, we're going to take 180 and minus the reference angle of 30 degrees. So we are talking about 150 degrees. So 30 degrees and 150 degrees both have the same reference angle of 30 degrees. Just the 30 degrees is in quadrant 1 and 150 degrees is in quadrant 2. So if our reference angle, or if our principal angle rather, ends in quadrant 3, and we're using a reference angle of 30 degrees, then we're talking about having our terminal arm, say, about here, because this would be 30 degrees. So what is our principal angle? Our principal angle is from the positive x-axis all the way to the terminal arm. So how much is that? Well, from here to here, right, the whole from one x-axis to the other x-axis, that's 180 degrees. And then we're just going to go 30 more. So the reference angle, or the principal angle, sorry, in this case is 180 plus 30 degrees, which would be 210 degrees. So again, 30 degrees, 150 degrees, and 210 degrees all have the same reference angle of 30 degrees. And that leaves us with just one final one, which is what if our reference angle of 30 degrees is in the 4th quadrant? That would mean a reference angle of 30 degrees is here. And so what's our principal angle? It's all of this. Well, how do I figure that out? Well, again, in the picture, I can clearly see that the principal angle and the reference angle make a total of 360. So if I take 360 and minus the reference angle of 30, I get my principal angle of 330 degrees. So all 4 of these angles, 30, 150, 210, and 330, all have the exact same reference angle of 30 degrees. So we have 4 angles that have the same reference angle. All right, so to determine 4 angles that have reference angles of 15 degrees. So essentially, doing what I kind of just did now with 15. So you can either sketch it out, especially for those of you that are visual, and trig is such a visual subject that sketch them out. Where would 15 degrees be if you're talking about having it in all 4 quadrants, right? So 15 degrees, if it's in quadrant 1, would be something like that. If it's in quadrant 2, it's going to be the mirror image just across the x-axis. or sorry, the y-axis. 15 degrees if it was in quadrant 3 as a reference angle would be something like that. And if it was in quadrant 4, it would be something like that. And so again, you're being asked to figure out what the principal angle is, what the primary angle is. Well, in quadrant 1, it's the same. So it would be 15 degrees. In quadrant 2, right, if this is 15 degrees, we're figuring out what that is. So that's 180 minus 15, or 175. No, sorry, 65. Silly me. 165. Okay. When the reference angle is here in quadrant 3, it's 180 plus 50, which would be 195 degrees. And when the reference angle is in quadrant 4, so our principal angle is going all the way around like that, it's 360 minus the reference angle of 15, which is 345. Okay. So what we have next is simply that summary of, okay, this is how you find the quadrant angles, this is how you find the principal angle for the 4 quadrants. In quadrant 1, reference angle and principal angle are the same thing. Okay. In quadrant 2, it's 180 degrees minus the reference angle, or conversely, that the reference angle is 180 degrees minus the principal. In quadrant 3, it's 180 degrees plus the reference angle, or the reference angle is 180 degrees, theta minus 180 degrees. And in quadrant 4, then, we find the reference angle by doing 360 minus theta, or 360 degrees minus the reference angle gives us the principal angle. Okay? So that's how we find those. So just a little summary there for your notes. All right, so sketch the following angles and find the reference angle. This is, again, kind of doing what we've done, only now we're figuring it out. We're finding the reference angle instead of theta. So 30 degrees, we'd be here in the first quadrant, and of course the reference angle and theta are the same thing. So the reference angle here is 30 degrees. If, though, we're doing 150, well, where would 150 be just as the principal angle? More than 180, more than 90, but less than 180. So 150 might be something like this, right? Now your reference angle is here, so that's 180 minus 150, which is 30 degrees, right? These should all be familiar because we've already seen them before. Right? 210, greater than 100, 180, smaller than 270. So 210 might be somewhere like here. How do you find your reference angle? Well, we're going to take our entire angle of 210 and minus 180 degrees from it. That would get us 30 degrees. And lastly, of course, 330 would be over here. How do you find your reference angle? 360 minus 330, which would get us 30 degrees. So just the reverse of the question we did previously. Okay? All right, so determine the reference angle for each angle, sketch theta and standard position. and label the reference angle. So I would ask you to pause the video right here and do these for yourself for a second. Okay? And once you've got them done, hit play. So you're back? You got this figured out? Okay. So your reference angle, if your principal angle is 80 degrees, or sorry, 140 degrees is obviously 40 degrees, because 140 and 40 make 180, and your angle should be here. And there's your reference angle. All right, asked you to label the reference angle. So that's where 40 degrees is. If your angle is 320, again, your reference angle should be 40 degrees, which again, if we're sketching that out, should be something like that, where this again is your reference angle. Okay? Lovely. All right, what about if it's 240? Well, if it's 240, your reference angle would be 60 degrees. 240 minus 180. Because you should have this angle in quadrant 3. So somewhere about there. And your reference angle is here. So that's your 60 degrees. And if you were at 95, your reference angle then would be 85. Because if I put this in a sketch, 95 is just going to be a little bit off of 90. And so I'm going to have quite a big reference angle here. Because again, remember, it's an acute angle to the closest x-axis. So that's our reference angle, minus this little piece right there. Doesn't want to erase just a little bit. There we go. There's our theta. Our reference angle, rather. Okay, and so that is the end of our little lesson there on angles and standard position. So do your assignment for angles and standard position. If you have any troubles, let me know in our question and answer period. When you're ready, and after you finish this one, you can watch the second video where we're going to start section 2.2. I'm actually splitting 2.2 up into 2 sections. First one we're going to do this week too, because this angles and standard position stuff is so easy. Okay? Great, guys. Thanks. See you soon.